Hi, I'm going to explain the first exercise that is solved by meshes. Here is like the complete circuit. We decided to choose this platform to do it. First, we start to see all the components in our circuit, and I'm going to start to put the resistors and the dependent and dependent sources. Here we have the resistor. I'm going to start by connecting my resistors to my my dependent source, and well, now that I have like these components, I'm going to start to put the independent ones that are right. Now it's important to put like positive here in this voltage source, and if it's like positive in this way, negative in this way, and I'm also missing the ground. Um, mm, Now like this one and this one are converters of ampere and voltage, and what they do is like if I put like in this one 1 ampere, it multiplies by 5 or the value that we were putting, and those are the ones I'm connecting now. Okay, like what I'm doing here is because in the image we can see that IY is the same as here, so we can like say that we can connect this point to the small part of this converter, and that's why I'm doing like this loop right here. Then also I have to add like a little bridge between these two cables because it appears to be like this is a like we connected with the other, but it isn't. So I just have to add a little bridge between them so they are connected. And lastly, we know that the voltage should be connected in parallel. Therefore, we connect it right here and right like here. Yes, and I am missing to put the values. Here is 2 amperes, resistor of 20. And finally, just to know like the current and the voltage that we have in our circuit, we put these markers. Like we connected the voltage here in parallel, so we have to measure them here. And the current, well, the current we're looking for is right here, and the other one is right here. Also, we're missing our ground at this point. And that's all we only put play, and we got these values in these voltages. Right here we have 5.663, then 24.91, and here the current is 714.29, and here is 1.66, and that's all. That's for the first circuit.
Hi, now I'm going to explain the calculations for this circuit. Here we can see that, well, first we used mesh. Here we don't have any super meshes, but we have 4 meshes, 1, 2, 3, and 4. So we want to calculate IY and VX. So first we see that IY is I2 plus I4, and that VX is minus 50, and it's minus because it goes like this way, it enters through the negative side, times I2. So now we do our equations, we solve for our incognitas, for our own unknowns. And then we can see that we plug them into the calculator, and now we can see that IY is 0.71 amperes, and is correct because here in our circuit we can see that it's 714.21 milliamperes. And for Vx, here it's 24.9 minus 5.63 volts, and that equals 19.35 volts. Thank you.
Hi, I'm Jessica, and I'm going to build this circuit. So first we're going to put our resistors. We put them, so we have 1, 2, 3, 4, and 5. Now we put it in the directions that we are looking for. So we rotate them. Okay, and our voltage source. So here we have 1, and well, we can either choose to change the format for it to be easier, so we would have to rotate it. And we know that's 8 volts, so we have to change that. And our current source, it's right here. That's 1 milliampere, so we have to change that too. And another battery. So we connect it and change the symbol, the direction. Okay, and then we start connecting. So here we have no problem because we have dependent sources. It gets a little bit more complicated when we have an independent source, so it's okay. But when we have dependent sources, that's when it gets a little bit complicated. So we connect here and here, and we can put this one in here, and here and here. And we know that, well, the center is going to be our ground because we have multiple independent sources, so we're going to put our ground right here in the middle, and we're going to connect them to here, the center, and this one right here. And this one into here. Okay, and then we're going to put our independent source, or current dependent source. So we search it, and it's here, okay. So we put it here, and we connect it, and it's going to be a little bit complicated because here the current, we have to break the circuit in order for it to work. So we're going to put the first one right here, and the other part we're going to connect it to here. Because here you can see that IX is going right here, so we want to put that current in there. So the first one goes right here in this node where I put this, but then the second one connects into here. So instead of connecting these, we break the circuit and we connect it through the current. And then we just have to change the values for our resistance. So here it's 2, here it's 2 again. Here's 8. Well, 8K, but 8, 6, here's 3. Our battery gives us 16 volts, so we change that to. And here, well, what it does is that it multiplies the current that it's given, so by resistance, so it's multiplied by 4. And now we just have to put the measures that we want to know, so we connect them into the nodes that we are going to solve, or that we already solved, and my partner is going to explain. Here's the current. Okay, just. Okay, and we run it. That's it.
Hi, I'm Mariela and I will be explaining how we solve this circuit. We use nodal analysis, and we first identify our nodes, and we have 1, 2, 3, 4, 5 nodes, but we have a super node in here because it is a voltage source in between two nodes, so that is our super node, and we apply KCL to solve this. So we first so KCL explains that the current entering a node is the same as the current exiting a node, so we applied that to have our system of equations. But for the super node we have like two different equations, and the first one is that the voltage here minus the voltage in the other side is 16, so the difference is equal to this here. And we solve our system of equations and we obtain these values, and we can confirm these values are correct by looking at our simulator in here, and we see that we have the same values calculated in here, but we are not finished yet because we need to find the current Ix. So we define that Ix is equal, because of Ohm's law, we know that the current is equal to the voltage, and in this case is the voltage difference between V1 and V5, the nodes that pass through these 6 ohm resistor. So we obtain our equation that the current is equal to 1.68 milliamperes, and we confirm this in our simulator, and we have this correct answer. And just to add, our ground is this node here, because the ground is selected based on the number of branches, and in this node here we have 4 different branches, so that is our ground, our reference point of all of these nodal analysis. Thank you.